So this is the problem statement for the first assignment in the Skyfi Labs course. So we open e-tabs, press OK. So we go and take the new model option. Display units is in metric SI. Steel section database is Indian. Steel design code is IS 800 2007 and concrete design code is IS 456 2000. So number of grid lines in X and Y direction is 4 as per the problem statement, and the spacing is 6 meter in both the cases, in both direction. Total number of stories is 23 and the story height for both the bottom as well as typical story is 3 meter, and we edit the story data. So we have 4 set of stories 1 to 8, 9 to 14, 15 to 19 and 20 to 23. So first we make story number 8 as a master story and make all of the stories below story number 8 similar to story number 8. Now we make story number 14 as the second master story and all the intermediate stories similar to story number 14. Now we make story number 19 as the third master story and all the intermediate stories similar to story number 19. Remaining stories are made similar to story number 23 and we press OK. We select the grid only option and we go OK again. So the grid is now created. Now we can define the materials. There are 3 materials. First is M40 concrete. Second is a rebar material of IISc grade 500. And the last is another rebar material but different grade, mild grade 250. And now as the materials have been defined, we can go and define section properties. First the frame section, and we will begin with the columns. Give the material as M40 and set the dimensions. And we give the reinforcement details. Longitudinal bars as IISc 500 and mild 250 as the ties. Design type is as columns and the clear cover is 40 mm. Give OK. Now we copy the same properties to create 2 more columns. Same material but change the dimensions. On clicking the modifier show rebar, we see that the properties are the same as that of previously defined columns, so we give OK. Repeat the same property, same method to create the third column. Just change the dimensions and the remaining things are same. Now we can start giving the beams. Beams are created in a similar manner. Now we can give the depth and width dimensions and modify the reinforcement. Both the top cover and bottom cover are 25 mm each, and give OK. Now we copy the property and modify it to create the next two set of beams. Now we make the auto select option available by add new property and select the auto select list. We can give a suitable name and design type as concrete, and now we will get the 6 predefined concrete sections. Select all the columns and add them. Click OK. Follow the same steps for creating an auto select list for beams also. Now the frame sections are defined. Now we can go on and define the slab section. Give a suitable name. Slab materials M40 as per the program statement, and give thickness as 150 mm. Now as all the materials are defined, now sections are also defined, and now we can start drawing the elements. So we go to the first set of stories. We go to story 1. We begin with the drawing of columns. Select column auto select option. Set similar stories option and start drawing columns. Now the second set of stories. Go to the third set of stories. Any of the stories remaining in the belonging to the third set of stories. We left 2 columns in the previous set of stories, so we are adding it now. And now we can go to the third set of stories. And finally the fourth set. Columns are drawn, and now we can start drawing the beam. So go to the first set of stories. Let us select story number 1 and repeat the same process all over again. We select quick draw beams or columns option and select beam auto select properties. Make sure similar stories option is selected, and we start drawing the beams. Now we go to the second set of stories. to the third set. And finally the fourth set. Now the columns as well as beams have been drawn, and now we have to draw the slabs. So go back to the first set of stories. And start drawing the slabs. So we have to select draw floor or wall objects and select keep draw floor or wall. Select the slab properties, slab 150. Make sure similar stories option is selected and start drawing the slabs. On to the second set. To the third set. And finally to the fourth set of stories. So we have done drawing the columns, beams and the slabs. Now it's time for assigning the loads, and before that we will go to the base and convert all the joints to the fixity. Select one story option, select everything, and since only joints are there, only the joints will be selected. 16 joints selected. Go to assign joints, restraints, select fixity and apply. Now go to any of the stories and select all stories option and select all the slabs. A total of 147 shells will be selected, and now we can assign the dead load. Dead load is selected. A load of 2 kN per meter square is the dead load as per the problem statement, and click apply. Now it's time for applying the live loads, which is different for different set of stories. So we select similar stories. We select all the slabs in this given plan section. Total of 72 shells is selected. Go to assign shell loads, uniform and live loads. 5 kN per meter square is the live load. Similarly, we go to the second set of stories. Select all the slabs. 42 shells will be selected. The live load is 4.5. Click apply. On to the third set. Selecting the slabs, a total of 25 shells, then assign the live load, which is 4 kN per meter square for the third set of stories. Now moving on to the final set of stories. On selecting the two stories, two slabs, a total of 8 shells will be selected and assign the live load, and the magnitude is 3.5 kN per meter square, and click apply. Now it's time to give the cladding load. Actually we are drawing the cladding using auto draw cladding, so we have to explicitly give the dead weight of the cladding material. So we go to the first set of stories, select the beams lying in the periphery of the story. A total of 12 beams will be selected in this story alone. Therefore, a combined total of 8 into 12, 96 frames will be selected, and assign a distributed frame load, a uniform load of 0.2 kN per meter as the cladding load. Now repeat the process for the second, third and fourth set of stories for the beams lying in the periphery of each story. Now we have completed applying the dead loads due to cladding, but the point to be noted is that the topmost story number 23, won't be having any walls above it. As a result, the cladding load acting on the beams on the story number 23 can be deleted as it is non-existent. So set the mode to 1 story and select all the 6 beams of frames in the story number 23. Here it will show 6 frames selected. Go to Assign menu, Frame Loads Distributed, and select Delete Existing Loads option and click Apply. And now all the loads except the wind loads are applied, so we can apply the wind loads. So before that we have to draw the cladding. Select the Use Loads option and give OK. So the claddings are now drawn as it is visible in the 3D view. Now we have to define the wind load. Go to Define menu, Load Patterns, and give the new load pattern name. Select the type of load as wind load and the code as IS 1875 and 1987. Give Add New Load. Select the same load and give Modify Lateral Load. Now as per the problem statement, the building is located in Bangalore, which has a basic wind speed of 33 meters per second. Terrain category is 3 in Bangalore and the structure class belongs to C, as it is assumed to have a design life of 50 years. Risk coefficient is 1, and since the upward wind slope in Bangalore is less than 3 degrees, the topography or the K3 factor is also taken as 1, and click OK. Now the wind load is defined. Now we have to set the wind pressure coefficients on different faces on which the wind is blowing. So we move to the elevation view, select face A. The face A is believed or assumed to be in the windward side or facing the wind. So both section A as well as the faces in section B are having or facing the wind. So we select all stories option, select all the faces, all the cladding on the section A. So now 41 shells are selected. We move to section B and select all the exposed faces. Now a total of 65 shells are selected. We go to assign menu, shell loads and wind pressure coefficients. This is a building having a height of 69 meters and a width of 18 meters. So the H by W ratio is 3.83 and the length by width ratio is 1. And the angle with which the wind is blowing on the face is 0 degree. So from IS 875 part 3, the corresponding wind coefficients are 0.8, minus 0.25 and minus 0.8. For section A and B, the coefficient is 0.8 as per the court provisions. Select windward side and click apply. Now we go to the section D, which is actually in the leeward side. Make sure all stories is selected and we select all the faces, all the cladding faces. We move to elevation view C as shown in the title and we select all the faces again. A total of 65 shells are selected and we assign the corresponding wind pressure coefficient. As per the code, the corresponding wind pressure coefficient is 0.25 negative. Select leeward or sides and click apply and OK. Now we have to set the elevation to section 1. And we select all the faces visible from section 1 and we continue the same process for the remaining sections 2, 3 and 4. So we have selected all the faces that are exposed to the outside atmosphere or wind from section 1, 2, 3 and 4. Make sure all shells are selected from the bottom left corner. So 122 shells are selected. Go to assign menu, shell loads and wind pressure coefficients. Make sure leeward or sides are selected and the wind pressure coefficient is negative 0.8. Click apply and OK. Now we have applied all the loads that are given in the program in the problem statement, and now we can analyze the building. Go to analyze menu, click run analysis. For that we have to save the file. The file is saved and the analysis has started. So the analysis is complete and we can see the deformed shape of the building in the 3D view pane, and we can get the details regarding the displacement of each joint. Right click the joint to get a detailed information regarding the point displacements like translation, rotation and drift. Now it's time for designing the building and checking the various sections. Go to design menu, concrete frame design, make sure IS 456 2000 is selected. Go to design menu again and give start to design check. So the analysis and design differ by 705 concrete frames, so we will be repeating the analysis by assigning a higher section, a bigger sections to the section that are failing in this step of analysis, so give yes. Now there is a difference of 10 concrete frames. We would like to reiterate the analysis once more, and it should be fine by then. So all the concrete beams or columns that have been failing in the second step have been updated or redesigned to the most biggest section, the biggest section that we have defined. It should be fine by now. We go to the design menu to check whether all the members are being verified or passing the check. So click verify all members passed, and we are getting the dialog box as all concrete frames passed the design check. So the design is safe. Click OK. Save your model, and that's it.